All right, go ahead and have your 2022 state test questions out. I am going to go through all of them right now. If you have one wrong, you can fix it. This is kind of up to you at this point. I've already got your grades and all of those things, so you don't really need to fix anything at the moment. But if you would like to have the right answers down, so if you want to look back at something again later, that might be a smart move. Also, it might be a good idea to mark them correct just because that helps you pay attention. I know this is not exciting. I'm really sorry. But again, I tell you this, that if you are paying attention, this is reviewing a lot of the concepts that you will see on the state test. This will make you more confident for the state test. It'll help you get more correct on the state test. So even though it's boring, that's why we do this, okay? So the very first one, which equation has no solutions? I will tell you, every single year we see questions that talk about no solutions, one solution, infinitely many solutions. Usually it's a box and it'll give you an equation and you have to click, is it one solution, no solution, many solutions? Another equation and you have to click which one it is. So you have to be able to determine from an equation how many solutions there are. And so what you do is you just solve that equation. So like the very first one here, I have my 3x plus 1 equals 3x minus 1. If I move my x's to the same side, those cancel out. That gives me 1 is equal to negative 1. That is not true. Since those are not equal to each other, that means there is no solution. I cannot plug in anything for x here and the same number over here and get the same outcome on both sides. And the reason for that is because the beginning part is the same, but then whatever we have here, on one case we're adding 1, on the other case we're subtracting 1. So we're going to get different answers. Just to show you how the others work, if you look at B, so I subtract my x over, that gives me 2x minus 1 is equal to 3. This is just our normal equations where I'd put like my railroad tracks in to solve. Okay, and then add the constant to the other side. Remember, don't move the 3 because then you'd be left with nothing over here. So add the 1, I get 4, divide both sides by that coefficient, and I get 2. X equals 2, that means that is the only solution there is. That's one solution because I have x equals a number. On the next one, I have 3 minus x equals negative 3x. So on this one, wasn't a very good plus sign there, but we add x on both sides. Okay, if I moved this one over, there would be nothing left. Okay, so I add x over here, so that cancels out. Negative 3 plus 1 is a negative 2. Still have 3 over here. If I divide both sides by that negative 2, I'd have x on one side and 3 divided by negative 2 on the other. That is one solution, one possible answer that will work. Okay? The next one, sorry about that. The next one is letter D, and if you look at that, it's 3x is equal to 3x. I have that one right here. If I would divide by 3 on both sides, I'd have x is equal to x. Or if you think of it, some people like to do it as subtract the 3x to the other side, and then you'd have 0 is equal to 0. If you get a number is equal to the same number, that means anything will work. No matter what we plug in, it'll be the same on both sides. And that's because they are exactly the same on both sides. So whatever I plug in for x here, if I plug in the same thing over here, they will be the same. Okay? So make sure you understand that idea of no solution means they're not the same on both sides. One solution means that it's a variable equals a number, and infinitely many means they're the same on both sides. Okay? Number 2, when I look at this one, so I have two functions here. It says two linear functions, so they're both a straight line, and it says select a phrase for each blank box to complete the statement that correctly compares the two functions. Now, I told you before, anytime you see ordered pairs, I would do graphing. This is not one I would graph because the numbers are so big. You can't really put 351 very well on this, okay? So in this case, when you look at it, we're talking about the slope and we're talking about the y-intercept. Remember, slope is my m, y-intercept is my begin. So if they gave me this second function here, my n is my slope, my b is my bn, so slope, y-intercept here. Now I need to find those numbers for function 1. So your y-intercept is always where it crosses the y-axis. Well, the y-axis means, if I'm looking at a graph here, if I have my y-axis and my x-axis right here, if there's something on this line, that means my x value has to be 0. I didn't move right, I didn't move left, I just went up. So 0 and then whatever that number is. So anytime you have an x of 0 and then a y value, that is where your begin is at. So my begin is 351. So the first thing is, on this one, the y-intercept of function 1 is what compared to function 2? Well, function 1 is 351. Function 2 is 396. So I know 351 is less than 396. That's part B. Okay? Then the slope. My slope on this one was 9. My slope on the top one, remember, that is my y2 minus y1 over x2 minus x1. I can pick any ordered pair. I just picked the first two because I thought that was easiest. So on the top, I did my y2 minus y1 and my x2 minus x1. And then I did the math here. So that's 13 over 1, which is just 13. So if I plug that in, 13 here and my 9, it says slope 1 is what compared to slope 2? Well, 13 is greater than 9. So this answer is greater than for part A. If you wanted to write this as an equation, 13 was my m, my b value was 351, so you could have easily gone through and said, okay, 13 is bigger than 9, that's greater than, and 351 is less than 396, so that's less than. Okay. Number 3, on this one, when I looked at this, I always like to pay attention to what it says as this maps onto this. So the one you're starting with, this was my start, this is what I'm moving to. Okay? So if the first thing I did was translate 1 unit up, this would be here. If I reflect across the x-axis, because it's on the x-axis, it would stay the same. So that can't be it. However, I will say that some of these, if you would have accidentally started with this one instead, it could have been the correct answer. So make sure you know which one you are starting with. This one says translate up by 1 unit and reflect across the y-axis. That's not where it is. Next one is translate 1 unit down, so -2. Reflect across the x-axis. Well, now if it's 2 down, instead I'm going to go 2 up. That's exactly where that one would be. Okay? D is not the correct answer because it says 1 down and across the y-axis. So make sure you understand the difference between flipping over the y-axis and flipping over the x-axis. So that one should have been C there. I think I forgot to mention that if you have questions on any of these as you're watching the video, please star it or write a question mark and even write the question down, so that way when I am back I can go over it with you of whatever your question was, because I guarantee if you have a question, somebody else is probably wondering about the exact same thing. Okay? Number 4. Now, number 4 is really not that difficult. The tricky part is understanding what it's asking and trying to create a visual for it. Okay, so it says an increasing function, so increasing, we know that means it is going up, passes through x, y, and mn. So I just made up my own idea here, okay? I said it's increasing, and this is x, y, and this is mn. It passes through those two, okay? We have no context of what the numbers are, but it's going to ask us greater than, less than, all of those things. So I put numbers to them. And I said, okay, if this one's lower and we're going across, think about it as your graph paper here. Okay? If it's going across, you have something right here, and we'll just guess that number. that one right there. So if here is my x and y axis, okay, this one is 1, 1, and this one is 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7 and a half. Okay? That's all I'm saying. Just make up points so that we know here's x and here's y and here's m and here's n, so that we can kind of have an idea of what we're looking for in these numbers. Okay? I use 2, 3, and 7, 9 because it really doesn't matter what you're picking. You just have to make sense with this. 2 and 3 are lower than both 7 and 9 because it went up as it went. So if we're looking at this, x is less than m, 2 is less than 7. Remember, this part's supposed to be lower on the x-axis, so it's farther to the left, okay? And y is less than n, meaning it is lower down, so farther down on it. Same thing here. When you look at it, x is less than m, y is less than n. So no matter what, if it is increasing, that should be a true statement there, that they're both less than. Okay? This next one, solving systems of equations here. There's two ways to do this. We talked through one the other day that was doing it mathematically, algebraically, and when you look at that, remember this was the one that I told you our student teacher was doing, and 5x plus 2 is the same as y. So in the second equation, I can replace y with that 5x plus 2. And I can do that so that I get rid of that y here. Right now, if there's two variables in an equation, we cannot solve. So we're trying to get it down to one variable. If I replace y with something that is equal to it, now I have all x's in my equation. So from there, I subtracted 5x on both sides. It doesn't matter which one you move. You could have moved either and still gotten the right answer. Okay, that gave me 6 minus 5 is just a 1x. From there, I need to get the constants on the other side from the variable, so I subtract 1 on both sides, and that gave me x is equal to 1. I just rearranged it because I like my variables first. Okay. Once I knew what x was 1, all you have to do is plug it back in here. So 5 times 1 plus 2, well 5 times 1 is 5 plus 2 is 7. Or do it in the second one. 6 times 1 is 6 plus the 1 there is equal to 7. Either way, you should get y as 7. The other thing you do is you could graph them. Okay, this graph kind of looks funny, but this is what it would look like if you graphed them. So the first one, my begin is at 2, and my slope is 5. That's really up 5, right 1, and I made my line. This one, my begin is at 1, and my slope is really up 6, right 1. And if you do that one time, you find the point where they cross. They made this one pretty easy graphing-wise. So that point is at positive 1, 1, 2, 3, 4, 5, 6, 7. So an x value of 1, a y value of 7. So do not forget about the option of graphing things. If there's ordered pairs, try to graph it. If there is an equation, remember it's y equals mx plus b, and you can graph that. Okay? Number 6 on this one, it says a conversion chart between a number of quarts, Q, and a number of liters, L, is shown. Complete the equation to model L in terms of Q. So when you're looking at this, you need to know the relationship between L and Q. There are multiple ways to do this because this is a proportional equation. Proportional equations means it's in y equals mx form. It means that the b value is going to be 0 because if you remember for a graph, proportional means it's a straight line through the origin, so through that 0, 0 there. Okay. So when we look at it, since it's proportional, there's multiple ways to think it through. In the past, most people have looked at it as that either you take 1 times that amount to get to your L, so Q times that amount always gets you the liters, or people have noticed that as it goes up by 0.95, it goes up by 1, and it does that every single time. So either way is kind of a way to be looking at that for that equation. But you do have to make sure you write it as the equation. It's not just L equals 0.95. It's that I'm taking that and multiplying it by Q. That's how I equal the L. So like 2 times 0.95 is the 1.9. 3 times 0.95 is the 2.85. Okay? Number 7, on this one, the vertices of triangle EFG are given. The vertices of E prime, F prime, G prime are also given. And it wants to know which transformation. Well, guys, when you do a single transformation, you do the same thing on every point. So notice, I just picked one point to look at how did it change from E to E prime. I could have picked F and F prime or whatever, but I don't need to look at all of them, so I just looked at the first. Well, my E is -3, 4, and my E prime is 4, 3. So first of all, I saw they switched them around, and that told me right away what it was. The only one we switch around is a 90-degree rotation. But even more so, then I made the right one the opposite. If you make the right one the opposite, that meant you were turning it clockwise, because a clock turns to the right. Okay? Just to go over some of the others, because normally for these types of problems, you do not actually have to know the rules yourself. You just look at a picture and have to know, okay, what did I do? Did I translate it? Did I rotate it? Did I reflect it? What was the thing that I did? However, in this one, you had to know the rules. So if you reflect across the x-axis, remember, that means it's going up or it's going down. That's the x stays the same. The y becomes the opposite. If you're reflecting over the y-axis, left and right, the y stays the same, the x becomes the opposite. And if you think about it, like here, where my thumb is, when I flip it over, that just changed on the x-axis where it was. It was a negative number, now it's a positive number. Where my y, it did not shift up and down on my y-axis, okay? If you rotate 180 degrees, that's the one where they stay in the same order but both become the opposite. So again, the fact that they switched and my y became my x and my x became my y right away told me it was a 90-degree rotation. Number 8, which does not represent a function. This is probably something you do not remember very well, but this is a problem where you have to use your vertical line test. The vertical line test says if you can take your pencil or whatever and you go across the line and it only hits, and it's a vertical line, so notice mine is going vertical. If it goes along the line and it only hits the line once at every point, that means that it passes a vertical line test and it is a function. So that one passed. If you look here, I go across, there it is, I go across and it only touches that line once at every point. On this one I go across, it only touches once at every point. This one I go across and it touches the whole line all at once. That does not pass the vertical line test. That is not a function. Okay, so anything that is a function has to pass the vertical line test. Number 9. This one tricks a lot of people, and it's really not meant to be that difficult. So when you look at this, this was just a matter of writing the first part in scientific notation. The part that confuses people is that it is a rounded number because it says the word about. So in this one, it talks about the mass of an elephant, okay, and it gives the mass, but then they want you to write it in scientific notation and say what that exponent would be. So they rounded it just to 6 million, okay? So to write 6 million in scientific notation, it moves 1, 2, 3, 4, 5, 6 times. So that's really 6 times 10 to the 6th power because we moved it 6 times. Now, if this would be a really small number, less than 0, that would have been a -6, but it's not, okay? So there's where my 6 came from. The next one, the tricky part is you had to realize it was rounding it up to 200,000. So when it rounded up to 200,000, it was this number, and we look at it and it moves it 1, 2, 3, 4, 5 times that time, okay? Because there's less zeros than that one would have. So we rounded it up, and that would be 2 times 10 to the 5th power on that one. Now, if you got that part wrong, you were automatically, sadly, going to get part B wrong. But if you had that right, you would have the numbers here to go for it. So it says using the estimated values, not the original numbers, the estimated. That's the 6 million and the 200,000. Okay? So when you're doing that, it was using the estimated values. The mass of the African elephant is about 3 times 10 to the nth power times the mass of the silverback gorilla. Well, if we're working backwards on this, if I want to know how many times bigger something is, going the opposite way to solve means I'm doing the opposite of multiplying. The opposite of multiplying is dividing. So I take my 6 million and I divide it by 200,000. Now, you can leave it as scientific notation, or you could do it as the standard form. Either way, you're going to get 30. Well, they don't want 30 here. They want to know how would we write that in scientific notation. So if I move it over 1 time, that gives me 3. So 3 times 10 to the 1st power would be your answer for part B. Okay? The next one, this one hopefully was an easy one for everybody. They've had a lot of tricky ones so far, so hopefully this was kind of a break for you in this. So we have 64. Vertical angles are congruent. Corresponding angles are congruent. Alternate exterior angles are congruent. So those are all my 64s. Notice, x is not 64. So if I look, this is supplementary. It's a straight line. Straight lines mean they add up to be 180. So 180 minus the 64 gave me that 116 degrees for my x value there. Okay. Number 11 on this one. This was one that was kind of a Pythagorean theorem question, but I told you from the get-go they're never going to make it just a basic Pythagorean theorem for the most part. They're going to add some sort of trick to it that you have to understand. So on this one, it says which calculation can be used to find the distance between points M and P. M and P. So if I want to know the distance from here to here, the first thing says just count the boxes. If it's at a diagonal, you can never count them. Okay? This one says add the length MS plus PS and divide by 2. So 6 plus 4 divided by 2. Now that's taking the average when you add the numbers up and divide by how many there are, but we're not looking for the average. Okay? On this one it says find the difference between the length of MS squared and PS squared. This is a close answer, but this is saying a squared minus b squared. A squared minus b squared has nothing to do with a right triangle, okay? Instead, it's a squared plus b squared. So this one says square the lengths MS and PS, so a squared and b squared. Then take the square root of the sum. That part's probably the part that's trying to confuse you. So what that says is we need to add up a squared plus b squared. And when you do, you get c squared. Well, to get just c, you have to take the square root of those numbers. Okay, just like this here. You had this squared plus this squared, and you added them with the sum. Well, at that point, you have to take the square root. So that's why it has that part in there. So that is D as your answer. This next one, select all. Anytime they have the boxes, it means there is more than one answer here. Okay, so when we look at this one, you have 2 to the 3rd power times negative 2, or I'm sorry, raised to the negative 2nd power times 2 to the negative 4th power. Now, you can do all of the fancy math, or if you want, you can just type this in your calculator, figure out what that one is, type this in your calculator, figure out what that one is, and do the same on all of these guys, and it'll tell you exactly what it is, like on this one. If you type in 2 raised to the 3rd power, remember raised to is just caret button. So the next one, raised to the negative 2nd power times 2 raised to the 4th power. I get my answer. It's 1/4. If you don't know that, do second PRB and it changes it to a fraction. If I go through all of these and I get that 0.25 or 1/4, you know you have it correct. So you can just be typing those straight in. Okay? The math part of it is, if you have a power to a power, you multiply. So 3 times -2 is -6. If you want at that point, you can flip it over because any next negative exponent means you take the reciprocal. And at that point, when I multiply together, I have 2 to the 4th on the top, 2 to the 6th on the bottom, 4 minus 6, because anytime it's dividing, you subtract exponents. 4 minus 6 is -2. -2 means I have to take the reciprocal. Okay? Or at this point, you just do this and multiply it. Again, to me, use the calculator. If you can use the calculator, type it in. Anytime you have exponents, you can type it in. Okay? Number 13, easy one. We always like when we get to an easy one. That's where we get to relax, take a break. Okay? So triangle ABC is rotated and translated. That means it was turned and slid. That means it's going to be the exact same shape and size. There's no dilation, so they are still congruent. If I were you, I would use the names to help you. If I want EF, those are the last 2 letters, so I also want BC, the last 2 letters. So EF, BC, if this is 6, this also has to be 6. Okay? Guys, these show up so many times, I can almost guarantee you will see one like this on the test. Okay? You want to see one like this because these are the easy ones. You can kind of take a break when you get to them. You can breathe. You know what you're doing. Okay? Next one, 14. Which graph represents a function that is linear? Linear, remember, means straight line. Function means it's going to pass the vertical line test. So when we look at our options, this one passes the vertical line test. It only ever touches that line 1 point at a time. However, it is not straight. Next one passes the vertical line test, only ever touches it once, but not a straight line. Next one passes the vertical line test and is a straight line. C is the answer. D printed on the next page, so I will show it to you on this one. Again, it passes the vertical line test, only touches the line 1 point at a time, but however, it is not a straight line. It's 2 straight lines, but it's not a straight line altogether. Okay? On this one, it says the current population of a city is 8.35 times 10 to the 5th power people, and the city is expected to grow in population by approximately 1.6 times 10 to the 4th power people next year. What is the expected population of the city next year? So this is what it currently is. This is how much it's going to increase by. So if we want the total at the end, that means we need to add. So you can do it 2 ways. Again, you can do the hard way and just actually do the math. If you're doing that, remember, when you are adding with scientific notation, or if you are subtracting with scientific notation, if you are adding and subtracting, the exponents have to be the same or you cannot combine them. Okay? So you can do, make this one go up. Remember, if the exponent goes up, the factor goes down by 1. So it would be 0.16 times 10 to the 5th power. At that point, you keep the exponent and you add the factors. Okay? The other thing you can do is just type it straight in. If you want to do 8.35 times 10 raised to the 5th power plus 1.6 times 10 raised to the 4th power, you do that and you will get that. Okay, at that point you just have to realize this is going to be this answer because I would move it, the decimal over 1, 2, 3, 4, 5 times. Don't forget about your calculator. I cannot tell you how many times there are questions where you can just use the calculator and people forget. Don't forget about it. Number 16 on this one. Which expression is equivalent to 17 cubed times 17 to the 10th power? Well, if you remember, when you have the same base and they're raised to an exponent, that means we can add them. If we have x squared times x cubed, that's really x times x for x squared, and x times x times x for x cubed. At that point, we just add them all up. That is x to the 5th power. So the shortcut is just add those two together. So if I do 3 plus 10, that is this one. Okay? This is one that I'm not sure if it would work on here just because of the fact that they're really big numbers. Yeah, this one did not work in that case. So at least not work for what they were trying to get at this point. Okay? So you want to make sure that you understand when they have the same base, you add here. Okay? 17, another one that hopefully was easy. All you have to do is use your reference sheet. Once you have your reference sheet, you know your volume formula for a cylinder. We know radius is halfway across a circle where diameter is all the way across. Height. I know height's confusing when they turn it on its side, but height is always between the two bases. Since this is a cylinder, my bases are my circles. Okay? It's just they took the can and turned it on its side. If it's on its side, the height is going this way. Just like you're standing up and you lay down, your height's still the same. Okay? It's just turned. So, round to the nearest tenth. When you do this, make sure you know where your pi button is, times 8 raised to the 2nd power times 6.5. And you do have to round. You look at the 9, behind it was a 0, so we know it stays as a 9. Okay? Next one, 2 companies manufacture pens. The number of pens Y company Q produces in X hours can be modeled by the equation showed, and then we do the same thing for R, but it's modeled by a graph. So based on the models, what is the difference between the number of pens company Q can do in 8 hours and company R can do in 8 hours? So on this one, since I know that X is my hours here, they were nice enough to tell me that, I can just plug in 8 here. 250 times 8 means in 8 hours I can make 2,000 pens. This one was not so nice. I had to do the math. So if in 3 hours I can make 600 pens, that means I can make 200 per hour. So if 200 per hour times 8 hours, I can make 1,600. Now, the question, remember me, is the difference. You have to know what the word difference means. Remember from the very beginning of the year we talked about our phrases here. Total means add, difference means subtract, product means multiply, quotient means divide. So when it says difference, we're subtracting. The difference from the 2,000 minus the 1,600 is 400. Okay, this one can make 400 more. Number 19, an equation. You guys rock at equations. I hope you get so many equations because you're fantastic at them. The very first thing you have to do is distribute. That means multiply through the parentheses. 2 times 18 is 36. 2 times negative x, make sure you bring that negative down. That's the one mistake I tend to see here, is negative 2x. I went ahead and I know I told you before not to do more than one step at once, but I did 2 steps here. 3x plus 4x is 7x. Like terms, you can combine. At this point, now I have variables on both sides. I need to get them to one side. So the opposite of subtracting is adding 2x on both sides. That gives me 9x minus 9 equal to 36. I add 9 to both sides. That cancels these out. So then I have 9x on one side, and 36 plus 9 is 45. The very last step is to divide by 9 on both sides, and I get x is equal to 5 on that one. Okay? Number 20, this is the very last one. Okay, number 20 says, Carrie goes hiking on a mountain. The graph models her elevation over time. Now, if you are looking at this, I would make sure to look at first, what are the differences? Because a lot of times these start the exact same way. So notice, this says decrease, decrease, increase, increase. Well, if you look at the very first thing that happens, it goes down. That's a decrease. Right away you can say, nope, nope. Then I continue on and see where the changes are. So then it says no change in elevation for a while, no change in elevation for a while. Right here there's no change. So both of them are correct so far. Then the end. Then the decrease again at a faster rate, or this one says at a slower rate. If you look right here at this decrease compared to the beginning, it's going down a lot quicker, so that it's decreasing at a faster rate because it is steeper here. Slower rate would have meant that it's dragging out super far, so that it takes more time to get down that distance than it did over there. So that should be A on that one. Okay. I know I went through these very, very quickly. So again, if there was anything you had a question on, please make sure you are writing it down so that you can ask me or you can ask the substitute. But I wanted to make sure we could get that done in one class period, so I tried to talk as quick as I possibly could. So hopefully you had most of them right. Remember, they're never expecting you to get all of them right, okay? So do not panic if you were missing some of those. That's how the state test works, okay?